What's going on, y'all? It's Sean and Mathswap Tutoring here, and in this video, we're going to talk about solving a system of linear inequalities by graphing. Make sure you like and subscribe if you haven't already, and let's get right into it. All right, so I hit my camera here just because the little camera view will be in the way. But anyhow, we have these two equations here: equation number one, equation number two, and we're going to graph these and find their solution. Now, this is very similar to solving a system of linear equations by graphing, except because it's inequalities, the solution will be a little different. All right. Now, so let's look at these two equations. X plus 2y is greater than or equal to negative 12. Y is less than 6x plus 7. Now, the first thing we want to do is we want to graph the inequalities. But with this one right here, we need to rearrange it so that it's in y equals mx plus b format. Of course, it's no equals, but you know what I mean. That way, we'll be able to clearly see the y-intercept, the slope, and be able to graph it from there. Okay. All right. So let's rewrite it down here. X plus 2y is greater than or equal to negative 12. Okay. So I'm going to move this to the other side. 2y is greater than or equal to negative x minus 12. Now we're going to divide both sides by 2. So that's y is greater than or equal to negative 1/2 x minus 12 divided by 2 is 6. Okay, so that's this first equation written in y equals mx plus b format. Now, let's go ahead and graph the first equation. The y-intercept is negative 6, so we'll go down to, and I'm going to use two different colors here. So I use green for this one. So negative 6, 1, 2, 3, 4, 5, negative 6. And then the slope tells us how to go over, I mean up and over. So down, so really in this case, down 1 and then over 2. So down 1 and over 2. Okay, down 1 and over 2. Now, just remember if you want to graph points in the other direction, which you don't have to, but I like to do it, then you need to do in the opposite direction. That means you'll go up 1 and to the left 2. So up 1 and to the left 2. So you just kind of reverse the order, and that tells you where the points go in the opposite direction. Okay. Now let's draw a line at least as best as I can to connect these points. Now, because this is greater than or equal to, that means we're going to do a solid line because it literally means y is either equal to negative 1/2 x minus 6 or it's greater than that. So because it's equal to that line, then that means that the line is solid. Okay. That's just basically saying that um, that those every point on the line, um, every point on the line is equal to that. Okay, so that's a raggedy looking line, but you're just gonna have to deal with it. It's the best I can do right now. Hopefully it works with this other graph, this line that we have to graph here. Now, number two, y is less than 6x plus 7. So we're gonna go to a y-intercept of 7. 1, 2, 3, 4, 5, 6, 7. Okay. Now we have to go up 6 and over 1. Now, I can't really do that going as high as, oh, see, that ended up being in the same color. I thought I selected a different one. So let's graph some points in the opposite direction, which would be down 6 and to the left 1. So 1, 2, 3, 4, 5, 6, and to the left 1. So down 1, 2, 3, 4, 5, 6, and then right here. Okay, cool. Now, if you look at the sign for this one, it is less than, it doesn't have equal to, so that means we're going to have a broken line with this one. So once again, I'm going to do as best as I can to draw a broken line. So it looks something like that. All right. Now, the last part of this is going to involve us knowing where to shade. Now, for the first equation, x plus 2y is greater than or equal to negative 12, or in other words, y is greater than or equal to negative 1 half x plus 6. If this green line is negative 1 half x plus 6, and we're saying that y is greater than or equal to that, that means y includes every point in this line as well as every value of y above the line. So if the y-axis is the up and down axis, we want to shade values of y that are above this line. So in other words, we're shading everything up here because it's values of y greater than the line. So you got to visualize the y-axis above this line, okay? Now, it'd probably be better to color it in, but we're on the computer, so we're just going to make it work. All right. Now, for the other line, y is less than 6x plus 7. So we want to see values of y that are below the line. So if you look at the line, of course, it crosses at y equals 7. So we're going to shade on the other side of the line where y values are less than that. So that's down here, really below the line, or really kind of like to the right of the line in this case. Okay? Now, so the solution, so we see two things here. You have a solution to the system of equations. If you look here, that's the point that they intersect, which is, what's that? Negative 2, 1, 2, 3, 4, 5. So that's like negative 2, negative 5. So that is a possible solution to both inequalities, but also the place where the shading intersects is an area of possible solutions. So that's literally this region in between here, okay? Anything over here, because that's where all the colors intersected. You see what I'm saying? I mean, that's where green and blue intersected. So those are solutions to the system. All right. So let me know if that was clear. This is how you solve a system of linear inequalities. That's where the solutions are. Intersection point and where the shading intersects. Make sure you like and subscribe and have a good one. Hey, thank you for watching this video. If you need math tutoring or you need SAT math help, look in the description to find out how you can sign up today. Also, don't forget to like, share, and subscribe so you stay in touch with Math Swap Tutoring on YouTube. Have a good one.